Lesson 5 is basically looking at how to evaluate these logarithms. So the first part's just a bit of review, and we talked about that from lesson 4, so let's just skip forward to how to evaluate. Okay, so Kelsey was asked to evaluate log base 2 argument 8. Her work is shown below. We're going to look at her work, and we're basically going to summarize the steps on how you would evaluate. Okay, so she started with her logarithm, and she set that equal to an unknown variable. The unknown variable is basically what we're going to solve for. Okay, so first she represents the logarithm that she's asked to evaluate with an unknown variable. Step 2, what has she done from this step to this step? Okay, good. She's gone from logarithmic form to exponential form. So convert to exponential form. Okay, we have base 2, the power of e equals 8. 8, then we look at the next step. 8 is now turned into 2 to the power of 3. Do you guys remember what that's called? Common base. Good. So let's get a common base. And in this case, she's chosen the common base of 2. Once we have a common base, what do we do with the exponents? V equals 3. So we're setting the exponents equal to each other. Good job. Okay, we set the exponents equal and then solve. And then the last one is just summarize. Or I guess we can say evaluate. So whatever we figured out the variable equals, that's actually what the entire logarithm equals. So keeping those steps in mind, we're just going to practice a little bit with these examples below. Okay, so we have log base 3 of 81 equals some unknown variable. That's step 1. Step 2, we're going to take this and we're going to put it into exponential form. So we have 3 to the power of x equals 81. Then we need a common base. So 3 to the power of x will equal 3 to the power of what gives me 81? 4. Now that we have a common base, the exponents will be equal. So we say that x equals 4. And this x, remember, was what log base 381 equals. So our final statement is that log base 3 of 81 is equal to 4. Okay, we'll try the next one. Again, we have to set the logarithm equal to an unknown variable. Doesn't have to be x, I'm just choosing x. Then we're going to convert that to exponential form. So 4 to the power of x equals 64. Then we need a common base. 4 to the power of x will equal 4 to the power of what gives you 64? 3, very good. Now that we have a common base, x equals 3. And that x was represented as log 4, argument 64, so we can summarize that. Log base 4, 64 equals 3. Okay, we're evaluating this to equal 3. Okay, next up. Log base 7, argument 7 will equal x. So set it to an unknown, then change it to exponential form. 7 to the power of x equals 7. What's on this 7 that's imaginary? Power of 1. So x equals 1. If we sub that back in, we're evaluating at log base 7, argument 7 equals 1. Now let's just throw this question out to anything. So say we had log 25, argument 25, and we need to solve for that. No matter what number you put in, if your base is the exact same as your argument, x will always equal 1. Okay, so if your base is the same as your argument, it will always equal 1. Okay, let's try the next one. This one you have to be a little bit creative, so I'll give you a heads up on that. So set this equal to 0, then put it into exponential form. So we have 12 to the power of x equals 1. How can I change 1 into base 12? Chris?
I just know how to change base 12. Which is 1 in the power of negative 0. That way, base 12 to the power of 0.
No. But you're on the right track. The 0 exponent's what we need.
Yeah.
And you probably could do it reverse as well, actually.
Okay.
But let's just keep the base 12. Now I'm going to change 1 to base 12 with an exponent of 0. Anything to the power of 0 is equal to what?
1.
So is it fair to say that 1 is equal to 12 to the power of 0?
It's fair.
Thank you. So we're just changing the base by using the exponent 0. Anything to the power of 0 equals 1. So x equals 0, which means that logarithm 12, argument 1 equals 0. Now let's just see what happens with any base and argument 1. Let you guys get a head start on the steps. So first, set it equal to an unknown. Convert to exponential form. And then solve. Okay, log base b, argument 1 equals x. Exponential form, b to the power of x equals 1. Let's do it Chris's way, actually. Let's make b base 1. So to do that, I need to go b to the power of 0, to the power of x equals 1. Okay, and let's just see. This actually won't work, because what's going to happen is the variable is going to be wiped right out. Okay, so we can't actually do it this way. But it was a really good thought. You knew that you needed 0 exponents, so that was an awesome start. Okay, but I just wanted to show you if you tried it this way, you'd be wiping out that variable. So it's not going to work. Which means b to the power of x has to stay. And we have to change 1 to a common base of b. b to the power of what? 0 equals 1. Good. Okay, and then we know x equals 0. So what can we conclude? No matter what the base is, if your argument is 1, what will it be? 0. Good. Okay, and we've done a question like this already, but let's try it with some unknowns. So first put an unknown variable, then we're going to set b to the power of x equal to b to this imaginary 1. So x equals 1, which means a log with the same base as its argument will always equal 1.